Welcome to a lesson with Dr. Powell. Let's take a look at finding the equation in 3 dimensions, vector equation between 2 different points. Suppose this point is 1, 5, 7, and this point is -2, 3, 4. And we want to find the equation of any line that will pass through these points. Well, let's go from the origin here and think of a vector that goes to there and a vector that goes to there. So we can change notation here to tips, represent vectors. Okay, now how do you find the vector that goes between these two guys? Well, by subtraction. So take -2, 3, 4, 1, 5, 7, and subtract. So we end up getting -3, -2, and -3. Okay, so this right here represents, in standard form, if we were to shift this to the origin, this vector right here. So maybe we'll call this vector v, maybe. Now the equation of the line can be thought of as starting from this vector here, maybe 1, 5, 7, and then you add v this way, you get to a place on the line. Well, what if you multiplied by 1/2 of v? You'd also be on the line, or 1/4 of v, or maybe -1/2, or -v, or 2v, you'd still be on the line. In fact, you get all the points of the line by just taking different multiples of v by rescaling it, by multiplying v by something, multiplying it by anything. Well, let's just let that anything be free, be a parameter. T times v is what we're adding to the original point. 1, 5, 7. And that is going to be our vector function. That describes the line. A lot like mx plus b, if we will. If we think of this as being like slope times t, or times x even, like mx plus b, where b is like the starting point. Very analogous, very similar. So here we can think of t times, now this vector is -3, -2, -3, plus 1, 5, 7. And then if we multiply that in and add component-wise, we should get our vector function as -3t plus 1, -2t plus 5, and -3t plus 7. And there's our vector function. Thanks for watching.